To find out the volume of a shape, just make a graph of the area of each two-dimensional slice along the length of the shape, which will sum up the cross-sections, and the area under the graph will be the volume of the shape. For a sphere, however, this process works in the same way, but is more complicated because the cross-sectional area varies quite a bit. However, we know that the area of each circular cross-section must be pi times the cross-sectional radius squared. And of course, if we plot the cross-sectional radius along the sphere, it obviously makes a graph in the shape of a semicircle. But for now, let's scale the x and y coordinates down by r. We can always multiply it back on later, and I'm keeping a record on this of whatever I've modified so I can reverse it later. Anyway, the reason why I simplified everything down to ones instead of in terms of r is because this equation actually plots a semicircular graph from -1 to 1 only. So now we know that the cross-sectional radius, big R, divided by, and not to be confused with small r, the radius of the sphere, equals the square root of 1 minus x squared. And remember, x is also divided by r. And now if we do pi times the y position squared, we'll get this. But as you can see, this is not the cross-sectional area. This is actually it, but divided by r squared. So if pi times 1 minus x squared is the cross-sectional area but divided by r squared, then this must be the actual cross-sectional area, because you then multiply everything back by r squared. But instead of plotting this, just to simplify the final area calculation of under the graph, let's get rid of pi r squared and we can multiply it back only. And the graph will just be an upside down parabola, because it has a negative x squared. And this area actually adds on the same exact way as the height increases in the graph of x cubed over 3 in this number range, and it ends up increasing by 2/3, and taking that away from 2, we get the area of this is 4/3. Finding out that the graph that does this is x cubed over 3, however, is an entirely different process, which is for another time. But multiplying everything back on, scaling it back up to the full, we get the area under the graph, and thus the volume of the sphere is 4/3 pi r cubed, and that is the answer.